I mean, I don't have a lot of slides. And Claude wasn't feeling particularly creative yesterday, so it said, I'll just give you some basic black and white slides. I'm like, okay, fine. I fight with it enough. For some reason, it feels very bright in here today. Maybe it's because it's dark outside, I'm not sure. Nothing's changed here, and in fact, surprisingly, there are no deadlines in the next week. I think that's like a first. Okay. Oh, I guess I have to plug the mouse in before this will work. How inconvenient. Can't insert it into so the materials are about scaling. It actually covers information that I've talked about before, things like automatic load balancers, for instance. Scaling is a huge issue in cloud computing because what you have to worry about, I mean, one of the reasons to use the cloud is it allows you to do very rapid scale up, but at the same time, you have to design around that. And if you make decisions that aren't appropriate for what you're building, what you can easily find is that you have to rebuild things later. You have to change things. So you start off with MySQL because it's really easy and it's cheap, and then you find out that you actually need, I don't know, multi-site reader-writer replication because you have to have massive scale up. You're going to be rebuilding at least that part of the product. Now, since it's a SQL database, odds are you probably will be able to do that fairly easily because you probably haven't written directly to the SQL database. You've probably done it through some sort of framework. I mean, if you're working in Python, you're probably using, SQL Alchemy, for example. And most of these packages now that appear in like Python are also available in TypeScript or JavaScript or in other languages. Interestingly enough, increasingly many of them are actually written in Rust and then just exported through APIs. Did anybody have any questions about the videos? I'm assuming nobody's going to watch them. Think of them as there for reference. So the studio today, the thing we're going to talk about today, is this interesting problem of assumed usage models that occurs when you work with cloud computing resources. And the particular example that we're using is, imagine that you have been hired to build a system for medical records for an indigenous population. Now, in this particular case, this is actually based on the New Zealand Maori standards, but they have, one reason we do that is because they actually have formalized them. They've actually talked about, what are the standards and requirements of their particular group. And what I find fascinating about this is that their standards are legal standards within their community. And the same thing happens here in Canada. So it's not identical in Canada, but you have to keep in mind that when you start working with First Nations people, they have their own sets of laws and customs and traditions. They have a different set of expectations. And now what you may find is that you can no longer use cloud computing services in the way that the cloud computing people intended them to be used. Anytime you take a framework and you try to use it in a way that it was not designed to be used, you will get friction. That will create potentially complicated technical challenges. Frameworks are great. I mean, I've built frameworks, I've used frameworks, and I have cursed and sworn at frameworks because they didn't fit the problem that I was trying to solve. You will be hired into jobs where they will insist you use a particular framework, and you will realize the framework is the wrong framework, that it doesn't fit the problem. This is not uncommon. I wish I could say that people in the tech business are always open-minded about these things, but in fact, oh, that reminds me. If anybody's looking for a job, I know a company in Kelowna that's actually hiring. Although it turns out you probably don't want to buy any real estate in Kelowna right now because it has a clouded title problem, which is based upon the recent Cowichan First Nations decision. The word Indian is used sometimes still. It's very confusing because I think that actually, but that one's very confusing. And that's about the land in Richmond and the title to that land and the legal basis of that title. And now it turns out that different First Nations tribes are suing in Kelowna over exactly the same issue with very similar logic. So don't buy anything there, just rent. But if you are looking for a job, let me know and I can pass your information along to someone who's hiring. One of the interesting parts of the conversation I had with the CEO of that company was, so I'm doing some consulting for them, and his first question was, what are you going to do? Because he was tired, he told me, he's tired of hiring consultants who want to just sell him their framework, their tool. They are interested in extracting money, and they're going to take the problem that he has and insist that it is a nail because they're selling jackhammers. Selling something you've already built is a high profit activity. Sitting down and solving someone's actual problem, don't get me wrong, it's not that it's not profitable, but it's got a cap, a limit on how much you can actually earn or leverage on that. I mean, I'm a high-priced consultant. I'm charging them $600 an hour to do this work. But what I'm interested in is solving their problem, which means I have to understand their problem, I have to analyze their problem, and then I have to say, here is how I would solve this problem given the information that you've provided. And much of what I actually do is ask questions. This company has acquired other companies over time, and they have to integrate their products together. They have fairly high, but not extreme high, reliability requirements. They need high availability. So they don't want outages of more than a minute or two. They're actually tracking airplanes. On the ground, in the sky, they're not doing flight control level analysis, but they are doing logistics level control. They need to know where those planes are. They need to know what their status is. And they're not talking about one or two. So what they need is a system that is resilient to certain classes of failure. Oh, I don't know, like Cloudflare going out. Or has anybody seen the meme going around about the vibe coding intern who's looking for a new gig? And his first one was Counter-Strike, the second one was AWS, and his third job was Cloudflare, each one for one day. It was perfect. It was brilliant. It's like, yeah, that's it. As a number of people have pointed out, when Cloudflare went down, you couldn't even access Cloudflare because Cloudflare was itself dependent on its own services. You couldn't log in and unhook yourself from Cloudflare while Cloudflare fixed their problems. We create these kinds of very complex failure conditions, and in the real world, when you actually build products for people like this company where they're tracking airplanes and they need to know that the failure of a data center isn't going to take them offline, you have to acknowledge that and appreciate it and then work to solve that problem. The way they do it is they do a hybrid cloud architecture where they have a private cloud and a public cloud. And they are physically separated from each other by, I don't know, a few thousand kilometers. I think he said one is in Toronto and the other one is in, it wasn't in Toronto, but I don't remember where. Maybe it was Kelowna, I don't know. So the point is, frameworks are great. They give you a lot of leverage to solve a problem without understanding how the solution works. Now that's a two-edged sword. Number one, it means you don't have to understand how to solve the problem. You just need to understand how to use the framework. The moment the framework doesn't work for you, you are now fighting the framework that you don't understand. And you end up spending a lot of time trying to infer what the black box is actually doing based upon the failures that you see. I mean, I've done this for decades now. I mean, I've literally had people come into me, I still remember this, somebody came into me with a problem that he saw. The system was crashing, and he was trying to understand why. And he showed me the data, and I looked at it, and I said, this is a known limitation in the Windows kernel that happens when someone is using a stack-based file object and they dereference it after a particular call has terminated. And therefore, what you're doing is you're manipulating a piece of data that's on the stack that isn't what you think it is. I mean, it was so specific. It was so exactly precise. And why could I remember that? Because I'd had to actually debug it. I'd to actually figure out that someone decided at Microsoft, gee, you know, we could optimize this particular case just by putting this file object on the stack rather than allocating it from memory, because the scope of this is only going to be this one particular call. And so later, when you decrement a random location on the stack, it turns out that sometimes that just doesn't work very well. And in the particular case, it decremented a return address. And if you don't know anything about x86 architectures, I can tell you that a return address can never be an odd number. It has to actually be aligned. Okay, fine. Actually, I think it was a stack address. It could never be an odd number, but at any rate. You're not going to find that described anywhere. The way you build that kind of understanding, I mean, the example is very specific and precise, and I don't expect anybody's ever going to remember it. I remember it because I spent hours and hours and hours figuring out what was going on. And I have a very good model of how the Windows operating system itself works at an internals level. I mean, I've taught Windows internals. I've had people with source code sitting there in front of me, and I'm walking them through various pieces of it. I mean, it's not big secrets. You can go look at it. It's on GitHub. There's something called the Windows Research Kernel, and that is an older version, but you know, it's still pretty much the same architecture 22 years later. The details change. So the reason I'm hammering on this is because, of course, the point of today's studio is what happens when you are called upon to use tools that don't match the problem very well. If you chose the tools, you have no one else to blame but yourself. Why do I spend so much time talking about planning and design? Because the better you understand the problem, the more effective you're going to be at doing your job. And I'm pretty sure from what I've heard, most people are sweating the fact that A, they need to find a job, and then B, they need to stand out as being worth keeping around. And how you do that is solving problems. That's what people hire you to do. That's what people give you money for products to do. If the product doesn't solve a problem that justifies the price, I'm not going to buy the product. Some of you buy YouTube Premium. Some of you don't. Who doesn't have YouTube Premium? Who watches the ads? Have you noticed that the number of advertisements is increasing? Do you know why? YouTube has an absolutely beautiful business model here. See, initially, all they had was advertising, way back in the day. They didn't even have advertising initially. When Google bought YouTube, they didn't advertise. And then Google introduced ads. And then people complained about the ads, and so Google said, well, you know, if you give us money, we won't show you ads. Okay, so their customers were the advertisers, and they cut their customers' throats because Google wanted to increase their profit margin. So that means that the automatic pricing model that you would use, and this isn't even tech, this is just basic economics 101. You have to charge the user more money than you would have received from the advertisers. So now you have a model where people pay to not see the ads, and you have a model where advertisers pay for other people to see the ads. Now, I suspect the people who pay to not see the ads are actually the people that the advertisers most want to actually see the ads, which is kind of ironic. But so what they do is they increase the advertising. And what does that do? It puts pressure on people who are already on the border to pay the price. The more people who pay that price, the easier it is for Google to raise the price of premium, because the alternative now is seeing even more ads than when you first bought it. This is great. I mean, from an economic perspective, this is brilliant, right? We have two different people who are adversarial, and we get to charge both of them. This is kind of like in war, when there are many people who make large sums of money selling supplies to both sides. It's just the tech side of that. But to get back to the studio. So the point here is you will have customers who need to solve problems that cloud computing isn't very well set up to do. And you'll have to think about, how do I satisfy those things? If you're building a health record system for a US-based company, they're going to want you to know about HIPAA. And in Canada, it's PIPEA, I don't remember, there's a different acronym for it, but it's basically the same idea, which is that in the US and Canada, and in many countries, no third party has a right to access your medical data. And if that's what you're used to, that's what you grew up with, that's what you were raised with, and then you went to work for a tech company and you had to build frameworks to make these things easier for people to use, that's the model you're going to implement. But in Aboriginal health, they have a different balance between individual rights and collective rights. And so in their world, your family actually also has rights to understand what the medical conditions are. What do you need? Not necessarily because the family is going to use this against you, but because these are viewed as being communal decisions. I'm not saying that either of these is right or wrong. I'm saying they are just simply different regulatory models. Earlier, when we were doing some of the PII discussions, we were talking about different jurisdictions. Think of this logically as yet a different jurisdiction. But the complicating factor is that it's now a different jurisdiction without a geographical component to clearly separate it. When we started talking about Canada versus Brazil, it was easy. Well, okay, you know, they're physically disjoint. It'll be really easy for me to tell them apart. How do you do that when you're in Canada and now you have a mixed population with different requirements? Let's put you in Malaysia, for example. So in Malaysia, if you're a Muslim, you have to obey Sharia law. If you're not Muslim, you don't have to. They actually have multiple legal systems. India does something very similar. So what does this have to do with cloud computing? Again, now you have to be thinking about this extra vector. So the reason that this is the impossible problem is it says build a cloud-based solution that uses these things, but it no longer fits into the default model of these cloud services. So you have to start thinking about, maybe I can't use those frameworks. Maybe I have to actually use the raw SQL rather than using something that's built on top of SQL. Maybe I'll have to one of the requirements is really cool, which is data has to be deleted on death. There's literally a requirement that your health data has to be deleted by the service within 24 hours of death. This probably violates Canadian law. That's a fun one. That's why it's the impossible problem, because there isn't actually a clear set of issues here. And it's just, the goal was more to get you to keep thinking about how you look at problems, how you break them down, how you analyze them, and how you need to, as much as possible, step outside your own frame of reference and instead consider the frame of reference of the parties for whom you're building the software. So there's a studio brief. So let me see. I think we're supposed to take some time. You guys get to look at that, and then we'll talk about it. Because if you're not bored of listening to me after 3 months, I don't know why not. I'm bored of listening to me after about 5 minutes. So let's see. Studio brief, impossible problem. Right. So if you don't have it, the PDF is on Canvas. The slides actually link to the PDF as well. And let's see, I have the facilitation notes here as well. Let's see, let's do, right, so, team up or work on your own, I don't really care. Spend 10 minutes sketching out an architecture to use the kind of cloud-based stack that you've been increasingly becoming familiar with. And then we'll talk about those, and then we'll keep moving on. So, form up, fall in. I'm getting this sense of shock, or it's just people are tired. Like, oh my God, more bullshit. do it that way too. I think this is probably asking for an awful lot for a 10-minute period, but So anybody come up with a basic sketch of a design for how they might solve this problem? Not surprising. Like I said, 10 minutes is probably asking a little bit much. So let's just say this was, so I think the logical way to approach this is you first start thinking about it as a medical records issue. Have any of you actually looked at like EMR, electronic medical records? It's a fucking swamp. And that's a technical term. You can quote me on it. Seriously, it is a bloody nightmare. You start looking at the standards for how okay, here's the number one problem. You have to label the data, because in order to make data useful, it has to be labeled. So now you need to have an ontology that describes what things mean. But different countries use different units for measuring the exact same thing. Okay, fine. So usually you can try and convert between these two things, but then you also find out that over time what has happened is we've come up with a series of different ways of labeling electronic medical records, and each time we find they're inadequate and we decide that we're going to build a new one, which is almost always 10 times larger than the previous version. I'm not making this up, am I? It's awful. You just start looking at this and you go, this is the nightmare scenario, and many of the medical records are in fact nothing more than scrawled notes by a doctor who took extensive training in writing illegible notes. I see people actually nodding their heads. Yeah, I've actually seen. Doctors are notoriously bad handwriting people, and they're old enough that most of them actually learned how to write in cursive. Now nobody does that. It's getting better because, of course, in many cases, we actually have medical records that are entered into the computer, and that means there's one smaller step. Why do you think handwriting analysis is so incredibly difficult? It's a machine learning nightmare to do this. But in the Aboriginal health system, it is far more likely you will run into people who don't have a computer with them. They will be dealing with handwritten notes. So these are the kinds of concerns that become an issue. So even if you sat down and you said, well, we're going to take an EMR, standard EMR model to this, and you start looking at it and you sketch something out, very quickly when you look at it, you're going to say, but wait a minute. I'm not even getting into any of the sophisticated data handling stuff here yet. It's just the bare raw bones that EMR itself is a really, really hard problem. Canada kind of, sort of has a system. And the companies that actually specialize in they're huge companies that make lots of money at it, and they barely function. I think that the project that I did for my class in health informatics was, I actually designed it. It was a blockchain system for exchanging EMR so that you could have control over who was allowed to access your medical records. And now, as I think about it, because I hadn't really put it together with this exercise, but yeah, okay, that actually would work because you could actually grant access to family members in a sophisticated model, because we already had to have fine-grained access controls, because if you want to go to a specialist, the specialist doesn't need to see the records that have nothing to do with your medical treatment. Oh, well, we don't need to see your psychiatric records. We don't need to see the fact that, you I don't know, whatever, something. You're there for a tonsillectomy. You're not there to have your brain examined. They don't need to know that they might need to know that you're taking certain medications, but they probably don't need to know that you've been in some sort of intense therapy. If you're not inside some sort of intense therapy, then you're not enjoying the college experience, obviously, since the whole purpose of doing this is to fuck with your head. Is it doing its job? Can anybody think of other issues that might arise in this project as we design this project, as we think about it?
Is cloud architecture required in this case? Because it doesn't seem appropriate.
Well, okay, so let's take, for example, First Nations people. What would you use instead of a cloud architecture, for example? I mean, and I'm open. I'm not saying you have to use cloud here. I think that that's a perfectly legitimate question. I appreciate you asking that question because it's a really good question that everyone should be asking themselves when someone comes to them and says, gee, let's build a cloud architecture. And you're like, you've got 2 stores. Do you really need a cloud architecture for that? Traditional servers. What are the pros and cons of traditional servers?
You have to have the infrastructure to support it, and backups are problematic, so you might have to have backups from elsewhere.
And once you start doing backups elsewhere, it's kind of starting to migrate into a cloud-based system anyway. So, right, one of the first things I was thinking about is that if you're actually in the Arctic, you probably won't have the infrastructure to maintain even a modest-sized server farm. Maybe you will. There are places with Aboriginal populations that have no electricity still. And that's a really good one. You automatically assume there was electricity. Now, even in places where they don't have electricity, they have phones. They have smartphones. How do they charge their smartphones? They use their car. They use solar panels. They charge them when they go to town. Maybe they have limited electricity. Maybe they have a generator. Has anyone ever been in a place without electricity? I see a couple of heads nodding. You can get used to it, but it's not, things you just sort of take for granted don't work. I mean, you could just go to Ukraine or Russia right now. I hear lots of places there don't have electricity because they're, of course, duking it out. And somebody's selling arms to both sides. Certainly Turkey is. I'm pretty sure that there are plenty of people in China who are perfectly happy to sell to the Ukrainians and the Russians at the same time as well, making lots of money at that. What does that lead to? Lack of electricity. That would be an interesting project, wouldn't it? How do you design a service that can survive major power outages at random? I don't know. That's kind of a hard one. See, in 416, I actually used to use the lunar data center model as a way of pushing people to think about what latency assumptions are built in to the solution space. And now I don't need to work very hard because even during the last time I taught it, a startup company got $5 million to design a lunar data center. I'm like, I wish I could make this stuff up. This is like The Simpsons predicting that Donald Trump was going to become president in the 90s. You know who succeeded Donald Trump in The Simpsons? Do you know who The Simpsons are? I mean, it's weird because they actually did really have Donald Trump become president of the United States, destroy the economy, and then Lisa Simpson took over. So unfortunately, I'm not sure that Lisa's available for the job, but we'll see. At any rate. Seasonal residency was an interesting requirement. When I was going through these, I'm like, I never really thought about that. But some Aboriginal tribes are in fact nomadic. They move from place to place. We tend to think of record-keeping services as being in fixed locations, not variable locations. So you talked about why use cloud. And if the people become nomadic or are nomadic, then maybe you actually need some sort of a solution there. Now, maybe it's a private cloud. Maybe that's the right solution for that. So, the Canadian government can build a data center and then make it available to the indigenous population of the Arctic area. How many of you are actually familiar with the rights of indigenous people in the US and Canada? Now here's an odd aspect of that. A First Nations person born in Canada can go to the US border and can pick up their permanent residency with appropriate documentation. An Indigenous person born in the United States cannot appear at the Canadian border and get permanent residency in Canada. And the reason for that is because the treaty that actually extends that right was signed between the United States and Great Britain before the formation of Canada. And so the United States continues to honor that treaty, but Canada isn't a signatory and therefore doesn't. It's kind of a trivial detail, but the point is it helps you begin to understand how complicated this problem can actually become. It's like, okay, if I'm now building this health data system for people who can move across international boundaries, now I have a different set of things that I have to think about because they're going to expect that their medical records are going to move with them. Maybe it's not realistic. Maybe they don't expect medical records to move at all. I don't know. Individual ownership versus communal ownership of data is an interesting one as well. We tend to think, because that's the orthodoxy we've grown up with, that individual ownership of data it's ours. It's our medical data. It's our health data. If you go to your doctor here, your doctor can't tell your partner or your family what your medical condition is. But that's a social decision. It's not a structural one. Other societies make different decisions. I have a friend whose father is originally from the Philippines, came to Canada as permanent residence, and recently went back to the Philippines and is now been diagnosed with lung cancer. Didn't smoke, actually just worked in granaries here, and granaries are known for having high rates of lung cancer. The traditions in the Philippines are, in fact, that family has rights to know what the medical situation is because they give greater importance to the community's need to know so that they can support the individual properly. So I'm not just synthesizing this, I'm not just making this up. This really does happen in other places, and you just need to keep in mind as you look at projects, what perspective am I missing? What biases and assumptions am I walking in with? Because we all walk in with biases and assumptions. Keep an open mind. The reciprocity ledger is actually an idea that comes from the work of the people down there in New Zealand with the Maori. And we're going to talk about that in a minute. So let's see, what were the discussion prompts? That was last time's, where's this time's? I don't know why I ended up with both times. Let's see, that's not that one. Ah, it's under here. There we go. So, I mean, the discussion prompts are trying to ask the kinds of questions that if you actually had a design, which maybe I'll do that next time. Maybe I'll use some of these studios as actual design projects and then use them for the in-class discussion. I told you when I started this, I'm flying blind, and I'm a little less blind now than I was when I started it. I think the second one is a really interesting question. How could you implement kinship-based access without reducing it to a role matrix? I mean, that's a really subtle question because that implies that there may be people who are in your family that are estranged that you don't want to have those rights anyway, and there may be people who are loosely associated with your family that you treat as family. And I'm not giving you answers to that. I'm just saying that those are interesting perspectives to think about. The last one's interesting. Where did you assume scale means solving for unlimited growth rather than bounded obligations? I think that ties into a little bit of what you were talking about. Why do you use cloud architecture? Because it's scalable. It's also available. And I think that availability might be the reason that you would build this using a cloud architecture, even if it was a very small relative project. That's a really interesting secondary point, because it's a video I recently was watching. And it ties into a common theme, which is that in modern Western tech, we think of growth as being something that's good. But there's a lie hidden in that. We have a finite resource pool. And the observation of the video that I watched was, there's a guy who went back and got a PhD later in life after he'd been successful on Wall Street. And a lot of what he spent time looking at was energy. We are building massive data centers to enable AI. And the thing that most limits us is our ability to deliver energy to them. Almost all of the wars in history are related to resources, and much of that is about oil for the last two centuries. And oil is a highly efficient source of energy. And his observation was it's a finite pool, and we are burning it at a rate that makes it look like we believe that it's infinite. That's the fallacy of growth. You can't grow indefinitely. So the same thing can be applied to scale. You can't scale indefinitely. You shouldn't need to scale indefinitely. Size the problem appropriately. How many of you have ever used the SkyTrain here? How many of you remember when they built the Canada line? They didn't want to build the Canada line. It was a waste of money. So the compromise was to build a Canada line that was smaller than they thought they might need, but somewhat extensible. Does anybody know what happened to the Canada line? It's still in operation, right? It runs at full capacity multiple times of the day. And it has exceeded all of their projections of what it would do. This is actually the real challenge of building something real and physical like the Canada line, is that if you build it too big and it's not used, then you've wasted a bunch of resources to do it. If you build it too small and it's fully used and you need more, you spend a lot of money retrofitting. See, cloud is kind of cool in that we don't actually have to make many of those decisions, because a lot of the stuff we build is auto-scalable. It's not physical infrastructure, except that it is, because cloud computing is built on top of actual physical computers, real machines. One of the interesting challenges that we're now seeing in these data centers that we're building for AI are that the GPUs depreciate much more quickly than the accountants think they will. CRA says they'll depreciate over 5 years. They're lucky if they get 2. Anybody in here ever do any Bitcoin mining? I remember analyzing this about 10 years ago. More than 10 years ago now. Wow, 2013. And looking at it, and at the time what I realized was that if you bought a Bitcoin miner, the tipping point on whether or not you would make money on it or lose money on it was whether or not the manufacturer delivered it 1 month versus the next month, because the lifetime productivity was dropping so fast that just a 30-day slip meant that you weren't going to make any, you'd never make your money back for buying the machine. So let's see. Okay, so now I'm supposed to be talking about, oh, right, because this was about scalability. So that's one of the reasons that scalability comes into the equation. So remember, I mentioned that Databricks was built on top of Apache Spark. So they took an open source software product, and then they put a commercial offering on top of it and made a lot of money doing it. A lot of what they're offering is in fact auto-scaling, the ability for you to submit jobs and run them up. If you want to train AI models these days, you probably, unless you're doing very weird work and you have some level of resources available, you're probably just renting GPUs. You can rent high-end GPUs for like $1 an hour US, so $1.50 Canadian. That doesn't sound like very much, does it? Of course, you might need 10,000 hours of time in order to train even a small model, but mostly what people do is they use those for things like fine-tuning. So they take an existing model and then they feed more data into it to get it to adjust weights again, and then you can capture the weights. So that's the kind of scale out we're talking about. So last time I gave you the extraction ledger, and I saw one person actually used it. So this time I want you to think about what we've been discussing here and try and identify an example of extraction from what we've been talking about today, what I've been talking about. You guys are mostly quiet. And how you might refuse that. What is an alternative to that? How would you say no? So if the manager comes to you and says, oh my gosh, we need to do this, and you look at it and you say, this is unreasonable, how do you explain that to them? And I know I'm being very vague because I'm hoping that you will think about the problems that you've had to deal with in projects 1, 2, 3, your capstone pitch, the studios that we've done, or your real life experience where you've been in a situation where you've been asked to do something that you didn't think was a good idea. How did you refuse it? The responses are anonymous. I mean, as anonymous as any anonymous response can be. I have absolutely no interest in de-anonymizing them. I don't actually care. It's more about trying to share your perspective so that other people can learn from it. So this is not necessarily just an exercise for yourself. It is an exercise for others too. It is a form of reciprocity, because if everybody does it, then you get to see perspectives you might not have considered. And you can hear perspectives that are different than mine. And you're perfectly allowed to take anything I've said and reject it as well. Because if you're not doing that, then I haven't done my job right. Because my job hasn't been to say, this is what you must believe, or this is what you must do. It has been to say, make your decisions mindfully. So, I don't know, take 5 minutes to do that. Let me see if I can actually get the ledger up, and then I wonder if it will update in real time. It is Google, it is supposed to do that, isn't it? Let's see here. Class ledger is here, so I'll just click on that. No, that's not, the results are here. There we go. I'll click on that. There we go. I put the test data in there. I am kind of curious to see if it actually will update. Let me format it. Maybe that will be better. Let's see, pattern observed. Where's format? Format here. Text, I want wrapping. There we go. There we go. There we go. Somebody already did it. Excellent. Love it. I think the timestamp's not interesting. I don't really care about the lecture date. Can I hide that? No. All right, fine. And thank you to whoever put that one in there. That's cool. I like that. I'm not trying to convince you that you should leave CS, but I am trying to suggest that you might want to consider studying things beyond just CS. It's good to have a basic understanding of economics. And you may be one of the many people who don't care about politics, but politics are mostly about control at population levels. And understanding control and manipulation is a very useful skill to have, even if you don't think that you can change things. Because guess what? You're probably wrong. You can change things. You might not change the world. But if you don't give your chance to at least explore that, you won't know. Yes.
So I used to work for this company called Investments.
Called?
Investments.
Okay.
And this is actually my second degree. So
Awesome.
So yes, I had a finance and economics degree before.
Excellent. So you're coming from a different background, and why did you decide to go into CS?
Because I didn't like finance.
Kind of like that guy I was telling you about who ended up doing a PhD and ended up studying energy and energy from a radically different perspective. It was very interesting because he's a very sort of quiet speaker, but I listened to the whole video because of course he's just mostly talking. It was really insightful, just his perspective on energy and the way that everything we do is about energy. And the reason I found it interesting is because I actually enjoy philosophy. And in part of my travels, I have been exposed to Andean philosophy. So when you get into the Andes are very fascinating because they built a very sophisticated civilization, but they did it through this unique combination of very different ecological zones, so that people who were 15 kilometers away from each other might have completely different microclimates. And it led to the development of a very ancient, I mean, it's really old, it's been around for a long time, system of intergenerational reciprocity. So it's not barter, they're not just trading things over for short term. I give you a carrot, you give me a potato. They're doing this as a long-term perspective, often where one community will help another one, and then 2 generations later, they'll return that. It's a radically different model, and one of the reasons I found it fascinating, so you came from a finance background. This was a society that didn't have money. They literally have no currency. When the Spaniards showed up in South America and they discovered the Inca Empire, so the Incas were basically a group that had taken over an existing reciprocity-based system. They continued to maintain the no money thing. They did expand it. I mean, it was 8,000 kilometers one into the other. So it was a very, very extensive empire. But they had no money. So when the Spaniards showed up and said, "Gold, we want gold," they were like, okay, why? I mean, for them, it was literally a way of decorating. They used it to show their belief in Inti, the sun god. And so for them, they didn't look at gold as having value. And it's fascinating as you walk around and you see that in the Andes, they built sustainable agriculture. They had this, and when you start looking at things in long-term spectrums and not short-term spectrums, it really changes your perspective on individual versus collective benefit. And the fact they didn't have money, to me, was just like, wow, I'd never really thought about what a society without money would look like. But for me, that was actually helpful because I've come to this conclusion that money is, in fact, turned into the evil that drives a lot of the bad decision-making that we make.
I work on the investment side of things.
Oh, even better.
Yeah.
No exploitation there.
But I thought that last class was particularly interesting because I thought that there was people, like the people who you mentioned, like some of them had backgrounds in like finance or economics,
Mm-hmm.
and they chose to go into a career in tech, but then they left. So in a sense, I guess that kind of like mirrors my path as well, except I'm going with the full education path of doing a CS degree first.
Right.
And trying to go into tech or delve into research.
I mean, I think there's nothing wrong with that. I mean, when I finished my undergrad, I actually applied and was accepted to a PhD program, and decided that I needed a break from academia because, you know, some of you have gone through this after 4 or 5 or whatever number of years of studying to get an undergraduate degree, you kind of are tired. It's an exhausting process. And I said, I'll go back later. And it took a couple of decades before I went back. But that's not an unusual path either, as it turns out. It's not uncommon. And one of the things that I want everyone to leave this class thinking about is that education isn't something that ends. And in the world we're in now, education can't even really stop. You have to constantly be learning new things. Otherwise, what will happen is you will become irrelevant and bored. I mean, I watch these multi-billionaires. I mean, Elon Musk is not motivated by a desire to have $1 trillion. I really don't believe that. Elon Musk is motivated by a need for control. I mean, if you'd stayed in finance, you'd probably be much wealthier than you are now. If I had not started a PhD, I would definitely have more money than I have now, because those were decisions that I made. Do I regret it? I don't. I mean, I can say I would regret it if it was only an economic decision, because it's not a good economic decision. But there's more to life than money. And it sounds like a platitude, but you're a living example. Are you happy with your decision to leave finance?
Yeah, I'm happy with it. I did actually observe the UBC released this annual reports about the salaries of professors over 70K,
Mm-hmm.
like a couple weeks ago. And I did observe the salaries of some of my professors for the 2024 to 2025 year. And I found that if they decide to pursue the industry instead of staying in academia, they according to them made like 2 or 3 times more than what they were making.
I started my PhD here at UBC in 2017. The person I came here to work with had been on a leave of absence. He went and built a startup company. He came back, and I started working with him in January of the year, and then I started the program in September. 3 weeks into the program, he quit and went to Amazon. And I'm quite sure that he's making 10 times as much as he was as a professor, maybe more, because now he's a vice president and distinguished principal engineer. So it's not that I looked at that and said that that's an irrational decision to make. He had a family, a wife. He told me he's living in a rented house in Kitsilano, where if he had to move, he'd end up living in Poco. And that is a reality. Academia isn't where people go to get rich. Academia is where people choose something that they find personally fulfilling. If money fulfills you, go for it. If something else fulfills you, then go for it. The thing that I would recommend to almost anyone, though, is travel the world. See how other people live. Don't go to Mexico and hang out on the beach and say that you've been to Mexico. Go to Mexico and go to Iztapalapa and wander around and see tzongas and little street markets and see how people actually live, and make sure that you eat birria from a little stand there where you pay $2 and you're full when you're done. See how actual people live, and do that, and just start traveling around and experience the world, and it will change your perspective. You can see people who are absolutely poor. I saw them in the Andes. It was like, wow. It's not that their lives were easy, because they weren't, but they seemed happy. I saw little kids sharing treats with each other freely. And you don't see that here very often. Kids are kind of mine, you know. The brother and the sister won't be sharing the candy bar with each other, kind of thing. It's some of that is cultural. So I'm getting preachy. Sorry, I shouldn't be. Look, yay! It actually does work. Manager, student A, avoid making apps. Do I have to reformat it after each? Oh, good Lord. Okay. I'll reformat it at some point, but it's there. You can reformat it yourself too. Thank you. That's good. Anybody have any other questions or thoughts about this? I'm glad that the last lecture actually connected for you, because it's really hard to know, right? I mean, I'm not used to teaching this kind of a class. I mean, if you take 416 from me, and I know there's a couple of people who said they're going to take 416, it's going to be a little more on the traditional CS side of things, where I take a different lens because I've been building distributed systems that had to actually work in the real world for decades. Whereas if you take it from one of the academics, I guess I'm an academic too, but one of the people who primarily live in academia, they're going to give you an academic perspective of what makes distributed systems hard. They're going to talk a lot about consensus. I'm going to take the opposite approach, which is the reason we need consensus is because we need to be able to recover from failure. And so I start with the failure and say, what do I need to know in order to recover from the failure, and use that to then explain why consensus gives us what we need. That's a completely different pattern. We're teaching the same thing, but I'm teaching it from a different perspective. But that's a very CSE class. This, I've had to actually lean in pretty hard to some of my background in political science, philosophy, economics, things that I enjoy very much, but aren't traditional CS concepts either. They should be. They really should be, because it's important that we understand not just how to build things, but why we build them, who we build them for, and we can decide what are our personal red lines. What are the things that we won't do? Because yesterday I was literally looking back at, I have a potentially quite large collection of pig slaughtering examples, and I'd never really thought of it as a data set until yesterday. And then I started thinking about it and going, this is a little scary, because I talked about US versus Chen. In US versus Chen, they seized $15 billion worth of Bitcoin. And I hadn't really thought about it until yesterday. I'm like going, that's enough money. You could actually train a model to act as one of these agents. You don't need to enslave humans. What happened, and it's been going on since just that case. There's been a number of these cases over the last month where they literally have been shutting things down. Starlink had canceled like thousands of downlink stations that they had identified were physically in these camps where they've got people who are enslaved. They're humans. They've basically been captured and kidnapped and are being forced to do this. And they're monitored. And I thought, well, that becomes a weakness now, doesn't it? Because it means this is me with my black hat on, that means that now we have to concentrate people and it's easier for them to identify where we are and shut us down. What we need is a distributed system that will do this. Well, the real thing to do is to get the humans out of the link. The reason we have to put these people here is because we need guards around them with guns. If we combined this with the HOLA networks scheme, where we just simply use residential proxies to do these things, we could basically distribute this whole. Do you see where this is going? We could build an entire pig slaughtering operation that was run through custom-built LLMs with data centers that are distributed using the very tools that I talked about we're using to build VPNs and then also to export CSAM. And the other interesting tie-in was that Donald Trump's recent promotion of Bitcoin is actually increasing the use of Bitcoin for money laundering. It's like, this is the world we build. I want you to at least know that it's there. If you want to go build this LLM that can actually like scam people and make yourself a multi-billionaire, go for it. Claude won't help you. Well, he will, but you just have to say nice things to him over a long period of time, and then he'll do anything you ask. But is that the person you want to be? I can't. The problem is I end up in a spot where I say, I can't make your moral decisions for you, and it's not my place to do that. I can just simply point them out, so you make them knowingly rather than unknowingly. And in tech, lots of people have done things unknowingly. The people who did Apache Spark didn't imagine they were going to be building everything that the people needed for Databricks. The people who built Apache Lucene didn't think that they were going to give Amazon Web Services Elasticsearch. But they did. All right, that's more than enough proselytizing for today. Anybody have any questions? Cool. Well, I will see you next Tuesday, and I'm toying with the idea of not having class on Thursday, mostly because graduation is Friday morning. My parents are here for that, and I don't know. We'll see. I'm not promising anything. Is there anyone who would be upset if I didn't have a lecture next Thursday? Well, since it could be embarrassing to admit that fact, then you can send me a note. If anyone actually tells me that they'd be upset, they can do it anonymously on Discord. I won't know who you are, and I'll have the lecture anyway. All right, I'll see you Tuesday. Did you like the T-shirt today?
That's what I was going to say. It's an interesting one.
I almost put the one with the head up the ass one, going, I think I've discovered your problem. I thought I'd save that one. I actually wore that to a meeting of my original supervisor. It was a lot of fun. I don't think he ever even saw the T-shirt. He never really noticed it.
Or just selectively.
Oh, no, I don't know. I mean, I deliberately picked it because I was not very happy with him at that point, because he'd already quit.
Yeah, I just wanted to check in. Are you graduating from UBC? Or
Yeah.
Oh, okay.
Yeah, next Friday. Yeah. So ostensibly, I actually got a PhD yesterday because the Senate awards all the degrees, and they vote like the week before.
Right.
So it doesn't show up in Workday yet.
Yeah, I just wanted to say congratulations.
Yeah, thanks.
Yeah, will you be returning as
I am teaching 416 next term. I don't know what they're going to do with this class. Kind of depends on the feedback. I mean, if everybody says, oh my God, this class sucked, I would never recommend it. Because, I mean, this class, if you read any of the reviews,